Hey guys, and welcome back to another video on the channel. Today we're going to be following up on our polynomial video. This is part 2, and we're just going to be continuing with the questions we did in the previous video. So let's just start with example 4. The polynomial p of x equals x cubed plus 3x squared plus 2x plus 1 can be written in the form of x minus 2 multiplied by x squared plus bx plus c plus r, where b, c, and r are real numbers. Find the values of these numbers. Okay, so what we can do at the start is they're both equal to each other pretty much. So p of x is x cubed plus 3x squared plus 2x plus 1. But p of x is also this over here, x minus 2 multiplied by x squared plus bx plus c times plus r. So why can't we just equate the two once we multiply this stuff out? So what we're going to do here is we'll take care of this and multiply this out. So in other words, this here is the same as, alright, x multiplied by x squared plus bx plus c minus 2 multiplied by x squared plus bx plus c plus r. So this is going to be, alright, x cubed plus bx squared plus cx minus 2x squared minus 2bx, I believe. Yep. Minus 2bx minus 2c plus r. So this is also p of x. So what we can do is actually equate the two of them once we collect pretty much their like terms. Now we can see there's no other cubic terms, but we do see there's a couple x squared terms. So what we're going to do is try and group them together, and we're also going to group the x terms together. And the constants we'll leave by themselves. So in other words, p of x is, alright, x cubed plus x squared. So in other words, it's going to be b minus 2 times by x squared plus c minus 2b times by x minus 2c plus r. So this is equivalent to this. So in other words, why can't we just equate the two? So rub this out now and move the two of them together. So the reason why we can equate them is because, well, they're both defined as p of x. So if we want to find pretty much our unknowns, we just equate the coefficients. So what I mean by that is the x squared coefficient must be equal to this x squared coefficient. So in other words, this coefficient in front of the x cubed is the same as this one. So that means this coefficient here, the 3, must be equal to that. So in other words, we get 3 equals b minus 2. And we also get, alright, 2 must be equal to c minus 2b. And then finally we get our number 1 should be equal to minus 2c plus r. So here we can find b straight away. So b is 5. Substitute that information here. So 2 equals c minus 2 times 5. So you get 10. So move that to the other side. So c equals 2 plus 10, which is 12. And then finally we get, alright, 1 equals negative 2 times by 12 plus r. Move that to the other side. So we get 1 plus, and this is 24, equals r. So r equals 25. And then finally, that's all good. So we found pretty much our values of b, c, and r just by equating the two of them. Because they said, alright, polynomial p of x can be written in this form. So this is equivalent to this. All we did was expand it and equate the coefficients. And that's all you pretty much need to do in that example. Now let's move on to some actual questions pretty much. So, question 8, I don't know what question this is from. I just took screenshots of textbooks and thought they'd be useful. So this one, p of x, x cubed plus 5x squared minus ax minus 20. If p of 2 is 0, find the value of a. So in other words, when x is equal to 2, this whole thing is 0. So p of x is x cubed plus 5x squared minus ax minus 20. If I substitute in x equals 2 everywhere, this should be all equal to 0. Minus 2 times a minus 20. So that's 0. So we get 8. This is going to be 2 squared is 4 times by 5 is 20, so plus 20 minus 2a minus 20. We can see straight away those two cancel out, so we get 0 equals 8 minus 2a, so therefore we get 2a equals 8. Therefore, we get a is equal to 4 if you divide both sides by 2. So that's how we found a. Very similar questions to what we did in the previous video. Just putting them all in an exam style question actually. Right, let's take a look at this one here. So, p of x is equal to 3x to the power of 6 minus 5x to the power of 3 plus ax squared plus bx plus 10. If p of negative 1 is equal to p of 2 and they're both equal to 0, find the values of a, b, and find the values of a and b. So this is very similar to the one we did in the previous video where we had two initial conditions, but we also have two unknowns. So in other words, we're going to get two simultaneous equations pretty much to find a and b. Now I'm going to write my b's as capitals because, as you know, they look like sixes. Alright, so p of x is the following: 3x to the power of 6 minus 5x cubed plus ax squared plus bx plus 10. So if I substitute x equals negative 1, I should get 0. So p of negative 1, 3, negative 1, 6, minus 5 times by negative 1 cubed, plus a negative 1 all squared, plus b times negative 1 plus 10. This is equal to 0 because that's what they've stated in the question, so 0. Negative 1 to the power of 6 is going to be positive because that's an even term, so we get 3. This here is an odd term, so that's going to be negative 1 times by negative 5, which is positive 5. This here is going to be plus a because of the squared term. This is going to be minus b plus 10. So what we're going to get is, alright, a minus b plus 18 equals 0. So that's our equation 1 pretty much. So we'll move that to the side and use that in a second. Let's make that smaller. There we go. So now we do the same thing with our initial condition. So we've done this one and it gave us this equation here. So now we're going to use our second initial condition here and work out the rest pretty much. So rub that out and do the same thing with the different number. So p of 2 should be equal to 0. So p of 2, 3, 2, all 6, minus 5, 2 to the cubed, plus a 2 squared, plus b times by 2 plus 10. And this is equal to 0, so 0. And now we go work out 2 to the power of 6. So 2 to the power of 6 is the same as 2 to the power of 3 times by 2 to the power of 3. So 2 to the power of 3 is 8. So in other words, 8 times 8 is going to be 64. So we're going to have 3 times by 64 minus, this is going to be 5 times by 8, which is 40, I believe. Yep. 2 squared is 4, so plus 4a. This is going to be plus 2b plus 10. Righto, so 3 times 64. So 64 times by 2 is 128. Plus 64 to that. That's going to be, what is that? I'm not sure. 128 plus 64. Let's double check. 192. Yeah, that looks about right. So 0 equals 192 minus 40 plus 4a plus 2b plus 10. So 192 minus 40 is 152 plus 10, which is 162, plus 4a plus 2b still equals 0. Now you can see they're all multiples of 2, so if you wanted to, you could divide everything by 2. So 162 divided by 2 is 81. This 4a will be turned into 2a, so plus 2a. This will be plus b, and that's going to be equal to 0. So that's our equation 2 that we got from our initial condition, pretty much. So now we just rub all this stuff out, and now we've got to pretty much solve for a and b. But that's okay, because since we have two unknowns, we also have two equations, so it'll be pretty easy to solve. Righto, so if we look at both of our equations here and we move them together, there's two ways we can pretty much solve them. So the first one is substitution, make one in terms of the other, and the second is elimination. But if you see, if I add the two equations together, for starters, I'm going to get 3a, and I'm going to get 0b, which is awesome because I've eliminated one of them. And then it will just be plus 81 plus 18 equals 0. So now we've got ourselves an equation with one variable and just letters pretty much. One variable and just numbers, sorry. So what we're going to have is, alright, this is going to be 99 equals, and move the 3a to the other side, so minus 3a, divide by negative 3a, or minus 3, sorry. 99 divided by 3 is 33, so a is negative 33. Then we substitute that into either equation, either this one or this one down here, doesn't really matter. I'll choose this one at the top, so a is equal to, a plus 18 equals my b. All I did was move that b to the other side. So I'm going to have minus 33 plus 18 equals b. I'm not sure what that is. Minus 33 plus 18. So b is negative 15. And we can double check this, because if we substitute this into here, and we put in our initial conditions, we should get 0 now. So let's double check that. B equals 15. So, because we now know what this and this are, our new polynomial, or our original polynomial that we weren't sure about, is now this. So 3x to the power of 6 minus 5x to the power of 3. And this is a, so it's going to be minus 33x squared. And this is going to be minus 15x plus 10. So if I put in x equals negative 1 into this equation here, I should get 0. So p of negative 1 is going to be 3, negative 1 to the power of 6, minus 5 times by negative 1 to the power of 3, minus 33, negative 1 all squared, minus 15, negative 1 plus 10. Let's see what we get. Let's move that. Let's move that. So, p of negative 1, this is going to be positive 3. This is going to be negative 1 times by 5, so positive 5. This is going to be negative 33. This is going to be positive 15, plus 10. So what we have here is, if I add the 5 and the 10 and the 15, I get 30. So in other words, I get negative 33 plus 33, which equals 0. So the first condition works. Now let's just check the second condition pretty much, and it should work as well. So this is a good way how you can double check your answers in the exam. So even if you find like good whole numbers and you want to double check and you've got extra time in the exam, just checking this stuff here will pretty much, well, it will save you a couple marks, so it's just good to do. So substitute in 2 now. Right, so let's see what we get. So 2 to the power of 6, 2 to the power of 3 times 2 to the power of 3, so in other words 8 times by 8, so 64. 3 times by 64 is 192, I believe. I'll double check that out. Yeah, 192. So this first bit's going to be 192 minus 40, because that'll be 8 times by 5, and that's a negative, so negative 40. This is going to be 4 times by 33. I'm not sure what that is. 4 times by 3. Minus 132. This is going to be minus 30 plus 10. So, in other words, if I add 40 and 30, I get 70, plus this bit here will give me negative 40 plus 132 plus 30, negative 202, plus the 10 here gives me positive 202. So in other words, those two cancel out and you get 0. So that means that A is in fact negative 33 and B is in fact negative 15. So we've proven those are the correct answers. Okay. So let's move on to the final question of the video, and then that will be it for this part. This is just a basic introduction to polynomials. We've still got a lot more to do. We'll learn how to graph them and pretty much do long division as well. So it is known that x to the power of 3 minus 7x squared plus 4x plus 12 is equivalent to this for all values of x for suitable values of a, of b and c. And then it gives you pretty much the steps how to solve it. So unlike the previous question we did up here, for this example, it didn't give any steps. This question is actually giving you steps how to solve it. So first one is like expand and collect like terms. Find b and c by equating their coefficients. Hence write it in terms of product of 3 linear factors pretty much. Okay, hence find the balance b, so this is true. Right, pretty easy question at the moment because they've given the steps. It'd be a lot harder if they didn't give you any of this at the moment and they just said, alright, find B and C pretty much. So what we're going to do is exactly what they said. we're going to expand this side here. So we're going to have x plus 1 multiplied by x squared plus bx plus c. So in other words, this is the same as x times by x squared plus bx plus c plus 1 times by all this. So this first bit is going to be x cubed plus bx squared plus cx plus x squared plus bx plus c. Okay, so now that we've done that, we're going to pretty much collect the like terms, exactly what they've said here. So there's no x cubes, but there is x squared terms here. And then there is linear x's here as well. So in other words, our polynomial is going to be, alright, x cubed plus b plus 1 x squared plus c plus b x plus c. So if I rub this stuff out now, I can now equate my two equations and then equate the coefficients pretty much. So we've got this is equivalent to this. So x cubed minus 7x squared plus 4x plus 12. So this needs to be the same as that. Pardon me. This needs to be the same as that. So in other words, we get two equations. So minus 7 is equal to b plus 1. So we can find b very easily. And 4 is equal to c plus b. So move the 1 over to the other side. So b is minus 8. Move this guy into this equation here. So we get 4 is equal to c minus 8. Move the 8 to the other side. So we get 4 plus 8 equals c, which is 12. So b is minus 8 and c is 12. Okay. Now it says, hence write the product as 3 linear factors. Now you don't need to do long division because they've already said it can be written like this. So all we've got to do is plug this into here and this into here. And we can see it's already, one of them is in a factor. All we got to do is factorize the quadratic. So in other words, we get, alright, x plus 1, and then we get x squared minus 8x plus 12. Okay? So now we've got to think, alright, what two numbers multiply to give 12 and add together to give minus 8? Well, we got to think, are they going to be whole numbers or are they going to be pretty much some funny values? But looking at the numbers we have here, I have a feeling they're going to be nice whole numbers. So all we got to do is, alright, think of the factors of 12. So you got 4 and 3, 12 and 1, and 2 and 6. If I multiply 2 and 6 together, I get 12. If I add them together, I get 8 as well. So we want minus 8. So if I have minus 2 times by 6, and times by negative 6, that gives me 12 still. So if I factorize that, it will be, alright, x minus 2, and then x minus 6. So that's what this bit can be rewritten as, because it's two numbers that multiply to give 12 and add together to give negative 8. And now we've written the polynomial as a product of 3 factors, because you can see you got 1, 2, 3. So we've done that bit as well. Let x equal this. Find the values of b and c so that this is true for all of x. So this is actually a bit of a separate question to this, because they won't necessarily be the same b values, but all we can see is they've really completed the square in that last bit there. So all we got is, alright, take a look at this quadratic term here and think, okay, that's not a perfect square at the moment. So take your middle term, halve it, square it, and see what you get. So that'll be 9. So if I added 9 and subtracted 9, I get a perfect square. So in other words, x squared plus 6x plus 9 minus 2. That is now a perfect square of x plus 3. So if I go 3 times by 3, I get 9. 3 plus 3 gives me 6. This bit here is going to be, what's that? Minus 11. So now I've put that in turning point form. So notice how b is negative here. So negative b equals 3. So therefore b must be negative 3. Even though it's positive here, they put negative b here. So c is also negative 11, doesn't change. because there's no negative sign there. And that's the last one done, pretty much. Righto, I hope you enjoyed this video. There'll be tons more coming on this stuff because we still got to do long division, but these two first videos are just basically an introduction into it. I hope you enjoyed this video, and if you have any questions, leave some in the comments and I'll try my best to answer them. Thank you.